All right, in this video, we're going to talk about slope-intercept form, which is something I think a lot of you still remember, so you might be able to go through this video pretty fast. So by the end of this video, you're going to be able to identify slope and the y-intercept from any equation. You can graph a linear equation in slope-intercept form, so that means we'll have to change some of them into intercept form, and you can identify equations of vertical and horizontal lines. Now, for some of us that might need a little bit of a review of what slope-intercept form is, it is this great equation down here. And if you haven't seen me do this before, m is your slope, okay? So it is your slope, but this is how, what I say, this is how we move. And then your b value, that is your y-intercept, or I'll say that's how or where we begin. Now, before we can just graph in slope-intercept form, we have to identify, equations that are in slope-intercept form, and then from there pull that information out. So in number one, my slope is, well, first of all, it's in slope-intercept form, right? Y is by itself. That's the key here. So my slope is -7/8, and my y-intercept is 12. Now number two, notice how it's not in slope-intercept form. So what I'll have to do is I'm going to have to add 4x to both sides. So now I get y by itself. Y is equal to 4x minus 7. So from here I know my slope is 4 and my y-intercept is -7. In number three, they're just hoping to trick you because typically the fraction is with the x, but notice how this fraction doesn't have x. And so what you might want to do is just rewrite it so it's at the end. So my equation is really y equals 9x plus 5/4. So that means my slope is 9 and my y-intercept is 5/4. Number four I particularly like because for some reason this always plays mind tricks on us. Okay, it's in slope-intercept form. So what you might want to do is just rewrite it as y equals x plus 0 because somehow that makes it look like it makes more sense. Your slope is 1 and your y-intercept is then 0. So the reason I do this is because what if we don't get, if I'm asked to graph an equation, it's not in slope-intercept form, or it looks just a little different, it helps us to identify slope and y-intercept and then graph it. So in number 13, I notice it's not in slope-intercept form. The y is now by itself, so I need to move the 7x over. And so really my equation is y equals -7x plus 2. So my slope is -7 and my y-intercept, or where I begin, is at 2. So I begin at 2 and I'm going to go down 7. So I count 1, 2, 3, 4. Let me just show you with my little laser. So I'm going out 1, 2, 3, 4, 5, 6, 7. And then over 1, there's where I'm going to put my point. Okay. And that's all that fits. So that's all I can do because otherwise I usually say, like, as a rule of thumb, I want at least 3 points. Number 14, okay, we have f of x. Y'all, f of x is the same thing as y. So if you need to, rewrite it as y equals x plus 1. So that means my slope is 1, my y-intercept is 1. So I go here, here's 1, and I go up 1 and over 1. And number 15, okay, it's also not in slope-intercept form again, so that means I have to subtract 3x over. So my equation is now y equals -3x plus 5. So my slope is -3 and my y-intercept, or where I begin, is at 5. And so I go to 5. Now from 5, I'm going to go, my slope is 3. So a lot of times I'll say if you need to write it as a fraction, so -3 over 1, just to remind us, okay, that means I go down 3. So I go 1, 2, 3. Over 1, and so that's where my point would go next. Okay, so down 3, 1, 2, 3 over 1, 1, 2, 3 over 1, got my 3 points. All right, number 16, we have a fraction. So again, f of x, same thing as y equals. It's important to know that. So my slope here is 1/3 and my y-intercept is -1. So I'll start at -1, go up 1 over 3. So again, just to show you, I go up 1 over 1, 2, 3. I'll do it one more time. So I go up 1 over 3. Now let's just say, okay, let's say I needed another point, or my graph, I ran out, and I needed to go in the opposite direction. And actually, before I even continue that thought, I'm off by 1 on that one. So like I was saying, if I needed to go in the opposite direction, I know I need a point over here. I can just, instead of going up, I can go down 1 and over 1, 2, 3 as well. Okay, that would be 2 negative movements, which still makes it a positive slope. Now in number 17, I notice I don't have an x. Okay, so I could technically rewrite that as y equals 0x plus 4. So that means my slope is 0 and my y-intercept is 4. So I go to 4. If my slope is 0, it's a horizontal line just passing through that axis. And so a lot of times I'll say, okay, whatever variable you see and it's equal to that, just that number, you draw a line through that number, through that axis. So then in number 18, okay, I see x and I see -3, so I go to -3 on my x-axis. I can't draw a horizontal line through that, so I make a vertical line. You might also hear me use the acronym as well, which is VUX and HOI. Okay, you'll hear me say this a lot. So what this means is that you'll get a vertical line, okay, vertical line with an undefined slope, which means I have an x equals equation. And then the HOI means I have a horizontal line, so horizontal, which means I have with a 0 slope, and it's a y equals equation. So it's another way of remembering when I have a y equals, what does that look like versus an x equals. So again, so another example, okay, so I'm graphing y equals 7. So one way of looking at it is I know that's the HOI. So that's horizontal 0 slope through -7. So that would be right here. And it also crosses, oh gosh, it also crosses that y axis. And it's a y equals. And then for the next one, I have x equals. So you might think, okay, that's VUX, so I know it's vertical. Or I know it's going to pass through that point on that axis, make it vertical. So you should just be able to identify whether or not I have a vertical or a horizontal line just by looking at the equation. So in A, first of all, I always want to get y by itself. So I'm going to add 4 to both sides. So that gives me 14. Or better yet, this gives me y equals 14. So in my head, I'm thinking, okay, it's y equals, that means it's HOI, or it means it's horizontal. In B, first of all, I'm going to rewrite this. So y is over here, y equals -6x. X and y are still in there, so it's neither vertical or horizontal, it's just linear. Okay, so I'm going to just put linear. In C, I'm going to get x by itself. Since I don't have a y, I'm going to get x by itself. And so I divide by 6, and I get x is just equal to 0. So because I see x, I know that that's VUX, so I know that means it is vertical. And then in D, I could get y by itself. This is a good one to review. So I'm going to subtract x to both sides. So that leaves me with -y is equal to -x plus 3. Then divide everything by -1, and I get y equals just x minus 3. Because I have x and y in there, I know it's simply just linear. So why don't you take a moment and let's just kind of review graphing on your own. So pause the video and try numbers 1 and 2. So in number 1, y is not by itself. So I'm going to divide everything by -2. This is an interesting try on your own problem, because this cancels, so then you get y equals, and this is a fraction that doesn't reduce. So just keep it as -3/2 or -3/2 x, and then plus 4. So see if you got that equation correct, first of all. So then my slope is just -3/2. My y-intercept is 4. So I go to 4. I'm going to go down 1, 2, 3 over 2. 1, 2, 3 over 2. Or in the other direction, I'll go up 3 and to the left 2. And then in number 2, you have to get y by itself always. So I subtract 1. I'm literally left with y equals -7. So hopefully you're thinking, oh, that's a HOI. That's horizontal. Or passing through that number through the y-axis. So I go to -7, I know it's a horizontal line, and there's your graph.